Welcome back, everyone. Ready for another deep dive.
Always.
Today, we're going back to the 17th century
Ooh, sounds exciting.
to explore the life and work of a guy named Christiaan Huygens.
Christiaan Huygens. I'm not familiar.
You might not recognize the name immediately, but trust me,
Okay.
this guy was a scientific ROCK star.
Wow, okay.
I mean, we're talking groundbreaking discoveries in optics, astronomy.
Oh, wow.
He even invented a revolutionary new type of clock.
A clock, huh? Okay, color me intrigued.
What I find fascinating about Huygens is that he wasn't just a brilliant theorist.
Right.
He was also incredibly skilled with his hands.
Oh, so a hands-on kind of guy.
Absolutely.
Yeah.
The Dutch, they have a word for this kind of person.
Do tell.
Vernufteling.
Vernufteling.
Basically, it means a clever inventor, an ingenious craftsman.
I like it. It has a nice ring to it.
So to guide our deep dive today, we're using excerpts from a Spanish-language biography of Huygens.
Interesting.
Our mission, should we choose to accept it,
I think we should...
is to uncover how this 17th century Vernufteling approached scientific problems.
Right.
And what made him such a unique figure in the history of science.
And that's important because...
Well, first we have to remember that the 17th century was a time of incredible scientific upheaval in Europe.
It was, wasn't it?
Yeah, I mean, new discoveries were happening all the time.
Left and right.
There was also a lot of debate, a lot of rivalry, sometimes outright conflict
Oh, yeah. It was a wild time.
between scientists and different schools of thought.
Oh, for sure.
And I think it's hard for us to really grasp
Right.
how scientists communicated back then.
No internet.
No internet, no phones, no quick emails.
No mail, I guess.
Yeah, most of their debates and discussions happened through letters,
Wow.
which could take weeks, even months, to reach their destination.
Yeah. Can you imagine?
Can you imagine waiting that long to get a response to a scientific argument?
I'd be pulling my hair out.
Talk about delayed gratification. But despite these, communication limitations,
Right.
there was this vibrant exchange of ideas happening all across Europe
Interesting.
and scientific societies, like the Royal Society in England
Oh, yeah.
and the Académie Royale des Sciences in France were starting to emerge,
Providing that platform, right?
providing a platform for scientists to share their findings,
Yep.
to debate their theories.
Mm.
So let's bring Christiaan Huygens into this picture.
All right, let's do it.
He was born into a pretty influential family.
Was you?
His father, Constantijn Huygens, was a well-connected diplomat,
Okay.
a poet, a composer,
Wow.
this all-around Renaissance man.
Quite the resume.
Yeah, he had close ties to some of the leading intellectuals of the time, including René Descartes.
Oh, wow. Descartes.
Yeah, so it sounds like Christian had a pretty privileged upbringing,
He did.
and his father was determined to give him the best possible education.
The best of the best.
So he's tutored in mathematics, mechanics, languages, music,
Wow.
even swordsmanship.
Okay, so a true Renaissance man in the making.
This broad, multidisciplinary education
Yeah.
definitely shaped his thinking and his approach to scientific problems.
I can see that.
So, he was kind of being groomed for this life at court,
You could sure.
but clearly science was his true passion.
It was, and he wasn't afraid to, challenge the status quo.
He wasn't, and even though he initially admired Descartes' work,
Okay.
he wasn't afraid to challenge some of those Cartesian principles
Interesting.
as he went deeper into his own research.
Makes sense.
That independent thinking, that's a hallmark of Huygens' work.
It is.
And speaking of independent thinking,
Let's do it.
let's talk about his groundbreaking work in astronomy,
All right.
starting with the mystery of Saturn.
Saturn.
For decades, astronomers had been puzzled
I bet.
by Saturn's appearance through their telescopes.
Oh, yeah. I've heard about this.
It seemed to change shape constantly,
Yeah, that's strange.
sometimes sprouting these weird handles or protrusions.
Handles.
It was a real enigma.
It was.
And astronomers came up with all sorts of theories to explain these bizarre observations.
So what were they thinking?
Some thought Saturn was egg-shaped.
Egg-shaped.
Others imagined these swirling vapor clouds or strangely shaped moons orbiting the planet.
Some wild guesses.
It's funny how even the brightest minds can get things so wrong.
Yeah, it happens.
Johannes Hevelius, for example, was convinced that Saturn was egg-shaped with these crescent-shaped extensions.
Hevelius. Okay, that's a new one.
And then you have Christoph Scheiner,
Shiner.
a German Jesuit astronomer, came up with this very complex theory
Okay.
involving vapor clouds somehow attached to the planet.
Vapor clouds.
Yeah, and even Christopher Wren,
Wren. Like the architect.
the architect, the one who designed St. Paul's Cathedral in London.
Oh, wow. That Wren.
Yeah. Even he got in on the action. He proposed this thin elliptical crown encircling Saturn,
Okay.
intersecting it at 2 points.
So he was getting closer.
Closer, but still not quite there.
Not quite.
It was Christiaan Huygens who finally cracked the code.
Okay, so tell me, how did he do it?
And here's the really mind-blowing part.
Okay.
He solved the mystery of Saturn's appearance when the rings weren't even visible.
Wait, what?
Yeah.
How is that possible?
So he spent 4 years meticulously tracking the movements of Saturn's largest moon,
Titan.
Titan, which, by the way, he also discovered.
Wow, okay.
By carefully analyzing Titan's orbit, he realized that something massive must be influencing its motion.
Oh, so he used Titan's movements as clues.
Exactly. He used Titan's movements as clues
Well,
to deduce the presence of something invisible.
That's brilliant.
So his observations, combined with his understanding of celestial mechanics,
Okay.
led him to the conclusion
Okay.
that Saturn must be surrounded by a thin, flat ring.
A ring.
This ring, when viewed edge-on from Earth, would disappear from sight,
Oh, I see.
explaining why astronomers sometimes couldn't see it.
That's amazing.
I mean, that is absolutely brilliant.
That is.
He essentially solved a cosmic puzzle using the laws of physics and a healthy dose of deduction.
Yeah.
But it gets even better.
Oh, there's more.
Oh, yeah.
Ah.
He didn't just announce his discovery.
Oh, no.
No, he did it in true dramatic fashion.
Okay, I like where this is going.
So in 1656,
Okay.
he publishes this short work on Saturn,
All right.
but instead of revealing his findings directly,
What did you do?
he presents them as an anagram.
An anagram.
He basically encoded his discovery to challenge his peers.
So a little bit of a, intellectual puzzle.
Yeah, and to protect his claim to the solution.
Oh, that's clever.
It was a clever way to pique everyone's curiosity
For sure.
while making sure he got the credit he deserved.
Yeah, he earned it.
The anagram, when deciphered,
Okay.
reads, "It is surrounded by a thin, flat ring, nowhere touching, inclined to the ecliptic."
Wow. Talk about a mic drop moment.
A mic drop moment in the history of science.
Totally.
So the reactions to this anagram,
I bet they were mixed.
they were a mix of amazement and skepticism.
Of course.
Some astronomers, like Eustachio Divini in Italy,
Divini.
refused to believe it until they saw the ring for themselves.
Well, I mean, can you blame them?
It was a radical concept
It was.
to imagine a planet with a ring system.
Right.
But as telescopes improved, more observations were made.
Right.
Huygens' explanation became widely accepted.
As it should.
He had revolutionized our understanding of the solar system,
Wow, what a legacy.
and his discovery of Saturn's rings opened up this whole new field of study in planetary science.
Yeah, it's incredible.
But his astronomical work didn't stop there.
Didn't it?
Not at all, no. He also made some remarkable calculations
Oh,
about the size of the solar system.
the size of the solar system.
Now, at the time, astronomers knew the relative distances between planets,
Okay.
thanks to Copernicus and Kepler.
Right.
But they didn't have a precise way to measure those distances in absolute terms.
I see.
So they knew Mars was farther away from the sun than Earth,
Okay.
but they couldn't say exactly how much farther.
Right. That makes sense.
And that's where Huygens comes in.
Okay.
He cleverly uses the phases of Venus to figure out the size of its orbit.
Phases of Venus.
And this, in turn, allowed him to calculate the distances to other planets.
Hold on, I'm not following. How did the phases of Venus help with that?
So, just like our moon,
Okay.
Venus goes through phases,
Right.
appearing as a crescent, a full disk, anything in between,
I've seen those pictures, yeah.
depending on its position relative to the sun and Earth.
Okay.
By carefully observing these phases
Okay.
and applying some geometry,
You're right.
Huygens could figure out the angle between Venus and the sun as seen from Earth.
Oh, I see.
And knowing that angle, he could then use trigonometry to calculate the distance to Venus.
Oh, that's clever.
It's a brilliant example of how Huygens combined meticulous observations
Yeah.
with his mathematical skills to solve a fundamental problem in astronomy.
He was a master of synthesis, wasn't he?
He was,
Bringing all these different fields together.
and his estimate, was it accurate?
Oh, yeah. His calculation for the distance between Earth and the sun
Okay.
was surprisingly close to what we know today.
Wow.
It's a remarkable feat considering the limited tools he had at his disposal.
It's mind-blowing to think that someone in the 17th century could make such accurate measurements of our cosmic neighborhood.
It really is.
It's like he was mapping the solar system with a combination of ingenuity, mathematics, and this keen eye for celestial patterns.
He was ahead of his time.
He really was a true pioneer in astronomy.
He was.
laying the groundwork for future discoveries, expanding our understanding of the vastness and complexity of the universe.
I'm ready to hear more.
Me too. So we've seen Huygens solve planetary riddles,
Yeah.
measure cosmic distances,
Impressive stuff.
but his scientific curiosity,
It didn't end there, did it?
it didn't stop there.
I figured.
He was also obsessed with building the perfect telescope.
Oh, the perfect telescope.
Yeah,
That's a tall order.
it is.
So how did that go for him?
Well, this pursuit led him deep into the world of optics,
Optics. Okay.
where, he made some really important discoveries
Yeah.
and even challenged some fundamental assumptions
Oh.
about the nature of light itself.
The nature of light. Now we're getting to some deep stuff.
Deep stuff, exactly.
I remember reading that he had some trouble with, the technology back then
Yeah.
for lens making.
He did. He really struggled with the limitations of lens-making technology at the time.
Oh, makes sense.
He could design these incredibly sophisticated lenses on paper,
Okay.
but the artisans who crafted the lenses,
Right.
they couldn't quite match his exacting specifications.
So like the ideas were there,
The ideas were there.
but the technology couldn't keep up.
Couldn't quite keep up. Yeah, it's
Like having a blueprint for a Ferrari,
yeah,
but you only have bicycle mechanic.
exactly. And that's
Yeah.
got to be frustrating.
Oh, incredible. So did that push him in any particular direction?
I think it did.
Like toward maybe exploring different telescope designs or?
It definitely played a role.
Yeah.
He even considered using mirrors instead of lenses,
Oh, interesting.
which kind of foreshadows Newton's later work on reflecting telescopes.
Oh, okay.
But before we get to Newton,
Right.
let's talk about his contributions to lens design.
All right. Lens design it is.
So Huygens, he figured out how to correct this problem called spherical aberration.
Spherical aberration. Remind me what that is again.
It's a distortion that makes images blurry.
Ah, right. Of course. So he was making telescopes sharper.
Sharper, even with those limitations in lens making.
Yeah. Very cool.
But sadly, he got scooped on publishing his findings.
Oh, no.
Yeah, this Cambridge professor named Isaac Barrow
Borrow. Okay.
published his work on correcting spherical aberration first.
Oh, so even though Huygens had done the work.
Even though Huygens had completed his research earlier.
Wow. Talk about bad timing.
It's a familiar story in the history of science.
It is.
Sometimes being brilliant isn't enough. You also need a bit of luck.
And good timing.
And good timing for sure.
So speaking of timing,
Okay.
let's shift gears a bit.
Okay.
Talk about Huygens' work on timekeeping.
Timekeeping, all right.
Now, before Huygens came along,
Yeah.
clocks were notoriously unreliable.
Oh, they were terrible.
Weren't they?
Yeah.
It's hard to imagine life without a good clock.
I know.
But they had to do it.
They did. And existing clocks.
Right.
They used things like springs or falling weights to track time.
Oh, okay.
But those mechanisms weren't very consistent.
I can see how that would be a problem.
Yeah, I mean, imagine trying to schedule a meeting
Haha.
using a clock that could be off by several minutes each day.
Yeah, good luck with that.
Chaos, right?
So what made Huygens' pendulum clock so special?
So Huygens realized
Okay.
that a pendulum swing,
Yeah.
it's incredibly regular.
Right?
No matter how wide or narrow the arc of the swing is,
Yeah.
it takes almost the same amount of time to complete one cycle.
I see. That regularity makes it perfect for keeping time.
Almost the same amount of time. Was there a catch?
Well, there was a slight issue
Oh,
called circular error.
circular error.
So a pendulum doesn't swing in a perfect straight line.
Okay.
It follows a slight arc,
Right.
and the wider the arc,
Yeah.
the slightly longer it takes to complete a swing.
Okay, so how did he overcome that?
With ingenuity, of course.
Of course.
He designed these special curved pieces
Okay.
called cycloidal cheeks
Cycloidal cheeks.
that guide the pendulum's swing.
I love that name.
It's a great name, isn't it?
It is. It's so descriptive.
And they do work.
So by forcing the pendulum to follow this specific curve,
Right.
he eliminates the circular error,
Exactly.
making the clock much more accurate.
So he literally used geometry to tame time.
It's amazing.
It is.
But as you might expect, his invention,
Yeah.
it didn't come without controversy.
There's always controversy.
Always controversy, right?
So who is he battling with this time?
So this time, he gets into a priority dispute with the royal clockmaker,
Oh, the royal clockmaker.
Isaac the Rat,
The rat.
who tried to claim credit for the invention,
Oh, come on.
even though Huygens had clearly documented his work
Yeah.
and presented it to the French Academy of Sciences.
Some people, I swear.
It seems like these scientific rivalries
Yeah.
and disputes over priority were a common theme in Huygens' life.
They were.
But despite those challenges,
Right.
his pendulum clock became the gold standard for timekeeping,
Yeah, it really did change things.
paving the way for even more precise clocks in the future.
And that's a legacy in itself.
It is. It's fascinating how his work on the pendulum clock
Mm-hmm.
wasn't just about building a better timepiece.
Right.
It was also driven by his desire
To understand, yeah.
to understand the fundamental laws of physics.
It's all connected.
The clock itself became a tool for scientific inquiry.
Absolutely.
And that brings us back to his fascination with light.
Light, right.
We mentioned earlier that he was skeptical of Newton's theory of color,
Yeah, the particle theory.
which proposed that light was made of particles.
Right, right.
So the nature of light,
Big question.
big question,
Still debated today.
was a hot topic of debate in the 17th century.
Yeah, I mean, it gets to the heart of things.
Yeah, was it made of particles, as Newton argued?
Right.
Or was it a wave?
As Huygens believed.
Yeah, it's a fundamental question about the nature of reality.
It really was.
And Huygens was firmly in the wave camp.
He was.
One of his arguments against the particle theory was that
Yeah.
if light were made of particles,
Yeah.
then light rays crossing each other
Okay.
would interfere and scatter,
Right.
but we don't see that happening.
Good point. So how did he explain the behavior of light?
So he proposed that light travels as a disturbance
Okay.
through a medium called ether,
Ether.
spreading outward from a source in spherical waves.
Spherical waves. I'm trying to picture this.
This idea of a wave-carrying ether was pretty common at the time.
Yeah.
Although, our understanding of light has evolved quite a bit since then.
Of course, of course.
It's one thing to say light is a wave.
Right.
It's another to actually explain how it works.
Exactly. So did he have a model
He did.
to explain how waves of light propagate?
He developed this brilliant and elegant model,
Okay.
now known as Huygens' principle,
Huygens' principle. I've heard of that.
which could explain how light refracts
Retracts.
or bends as it passes from one medium to another.
Like from air to water.
Exactly.
This is where we get to that famous principle.
Right.
The one about how waves move.
Exactly. So imagine a wave front,
Okay.
like the crest of a wave spreading out from a pebble dropped in a pond.
Okay, I can see it.
Huygens' principle says
Yeah.
that each point on that wave front
Okay.
acts as a source of new secondary wavelets.
Secondary wavelets, so like little mini waves.
Little mini waves
coming off the main waves.
coming off the main wave. So instead of one big wave,
Yeah.
you've got all these little waves radiating outward from every point along the main wavefront.
Wow, that's a cool visual.
And as those secondary wavelets overlap
Right.
and combine,
Yeah.
they create a new wavefront,
Okay.
allowing the wave to continue propagating.
So it's like a chain reaction.
It's like a chain reaction of tiny waves.
Very cool.
And this elegantly explains how light bends.
When it goes from air into glass.
Exactly. Because the speed of light
Ugh.
is different in different mediums.
Right.
Those secondary wavelets,
Yeah.
they don't all travel at the same speed.
Of course.
This difference in speed causes the wavefront to change direction.
Which we observe as refraction.
Exactly.
So he created this model
He did.
that explains how waves behave.
And he did it without any fancy calculus or modern physics.
That's incredible.
No, but did he ever definitively prove that light was a wave?
Well, not in the way that we think of scientific proof today.
Yeah.
That came much later
Okay.
with experiments like Young's double slit experiment.
In the early 1800s.
Yeah, but what's remarkable is that his principle, this idea of each point on a wavefront acting like a source of new wavelets,
Yeah.
it's still used today to understand all sorts of wave phenomena.
Really?
It's a testament to his deep intuition about the fundamental nature of light.
Even if he didn't have all the tools and experimental evidence that we have today.
Exactly. It's pretty amazing.
It's incredible how someone in the 17th century could come up with a concept that's still relevant to our understanding of the universe today.
Yeah, it makes you wonder what else he might have figured out,
I know.
given more time.
Right.
But even with all of this groundbreaking work,
Yeah.
it seems like Huygens was constantly running into roadblocks.
He was.
We've talked about those disputes.
The disputes with the clockmaker.
Right, over the pendulum clock.
Yeah.
But he also butted heads with Robert Hooke,
Robert Hooke.
another prominent English scientist.
Yeah. Tell me about that.
So they clashed over things like the invention of the spring-regulated watch and even the nature of light itself.
Of course.
So they really went at it.
It seems like those disputes took their toll on him.
They did.
They did.
He became much more hesitant to publish his work,
Really?
always striving for this absolute perfection.
Oh, wow.
Perhaps out of fear of being scooped again.
Yeah, it makes sense.
It's kind of ironic.
It is.
Because his perfectionism might have actually obscured some of his brilliance.
Interesting point.
I mean, what other insights might be hidden away in his notes,
Yeah.
just waiting to be rediscovered?
That's an intriguing thought. It's like there's this whole other layer to his legacy.
Right.
Waiting to be unearthed.
A hidden treasure trove of ideas.
But before we get lost in speculation,
Okay.
let's talk about his final work.
Okay, his final work,
Cosmothera.
Cosmotheros, or...
His swan song.
Yeah?
Published posthumously in 1698.
Okay.
It's this fascinating blend of science and speculation.
Oh, that sounds interesting.
It really is a testament to his boundless curiosity
Hmm.
and his willingness to explore the big questions.
Even without the tools we have today.
Exactly.
So, what kind of big questions are we talking about here?
So in Cosmotheros,
Yeah.
Huygens delves into the possibility of extraterrestrial life.
Extraterrestrial life.
He's envisioning alien societies,
Wow.
speculating about their anatomy, their culture,
Really?
even their technology.
That's amazing.
Imagine the kinds of conversations he would have had
I know, right?
if he could have seen images from the Hubble Space Telescope.
Or data from the Kepler mission.
I know, he was looking beyond the limitations of his time,
He was.
pondering the vastness of the universe
Yeah.
and the potential for other intelligent beings out there.
It's mind-blowing to think about.
It makes you wonder what he would have thought
Right.
about our modern understanding of exoplanets
Yeah.
and the search for life beyond Earth.
I bet he would have been thrilled.
I think so too.
It speaks to his incredible intellectual range.
It does.
I mean, think about it. He mapped the rings of Saturn. Yeah.
He figured out the scale of the solar system,
Right.
revolutionized timekeeping,
Mm-hmm.
laid the groundwork for our modern understanding of light,
Yeah.
and still have the time and energy to ponder the existence of aliens.
It's incredible.
He was a true polymath,
True polymath.
someone who saw connections where others saw only disparate fields.
Yeah. It's that ability to connect seemingly unrelated ideas. That vernuftling spirit.
That vernuftling spirit, I like that.
That makes him such a remarkable figure in the history of science.
He really is an inspiration.
And it's not just his intellectual achievements that are inspiring.
Right.
It's also his resilience.
That's important.
His willingness to keep pushing the boundaries of knowledge.
Despite the setbacks.
Despite the setbacks, the controversies.
Yeah, he didn't give up.
He was a testament to the power of human curiosity.
He was.
And the enduring quest to understand our place in the cosmos.
Beautifully said.
So we've talked about Huygens' incredible work in astronomy and timekeeping. Yeah, the range of his curiosity was truly remarkable.
But what really fascinates me is how he was able to connect these seemingly disparate fields.
Right, like what does measuring the stars have to do with building a better clock?
Exactly. But for Huygens, it seems like it was all part of this grand tapestry of knowledge.
It's like he saw the universe as this intricate clockwork mechanism.
Yes, governed by these precise mathematical laws.
And that connection, between the theoretical and the practical, that's what makes Huygens so unique.
It does.
He wasn't just this brilliant mind.
Right.
He was also a skilled craftsman.
Right.
Constantly pushing the limits of what was possible with the tools of his time.
Remember how he tackled the problem of spherical aberration in telescopes?
Oh yeah, he designed a solution using lenses.
Right.
But the artisans back then, they just couldn't build them to his specifications.
It's like having the blueprint for a Ferrari.
Right.
But only being able to find bicycle mechanics.
Exactly. And, I wonder if that frustration pushed him towards the wave theory of light.
Interesting thought.
Because he was a big critic, wasn't he?
He was.
Of Newton's particle theory.
Yeah, and, I think his work with Icelandic spar.
Oh, where he discovered the polarization of light.
Yeah, that definitely pointed him in the direction of waves.
It's hard to explain polarization with particles.
It is. Think about it. You have this crystal
Okay.
that splits light into two beams.
Yeah.
And each beam has this different, let's call it, sightedness.
Sightedness. I like that.
That just makes more sense if light is a wave.
Rippling through space.
Yeah.
Rather than a stream of particles.
And Huygens, he took that wave idea and ran with it.
He did. He came up with Huygens' principle to explain how light propagates.
Did he ever actually prove that light was a wave, though?
Well, not definitively, no.
Yep.
That came much later.
With-
The experiments like Young's double-slit experiment.
Right, in the early 1800s.
But what's remarkable is that his principle, this idea of each point on a wavefront acting like a source of new wavelets,
Yeah.
it's still used today. Really?
to understand all sorts of wave phenomena.
That's amazing.
It's a testament to his deep intuition about the fundamental nature of light.
Even if he didn't have all the tools and experimental evidence that we have today.
Exactly. But even with all of this groundbreaking work,
Right.
it seems like Huygens was constantly running into these roadblocks.
It does seem that way, yeah.
We talked about the dispute with the royal clockmaker over the pendulum clock.
Right.
But he also butted heads with Robert Hooke
Robert Hooke.
over the invention of the spring-regulated watch. And of course, the nature of light itself.
It was never ending, was it?
It seemed like every time he turned around, there was another controversy brewing.
And those clashes, especially with Hooke,
They took a toll on him.
I bet.
He became more hesitant to publish his work,
Really?
always striving for this absolute perfection,
I see.
perhaps afraid of being scooped again.
That makes sense.
It's ironic, though, isn't it?
It is.
Because his perfectionism might have actually obscured some of his brilliance. What do you mean?
I mean, what other insights might be hidden away in his notes?
Yeah.
Just waiting to be rediscovered.
That's an intriguing thought. It's like there's this whole other layer to his legacy.
Right.
Waiting to be unearthed.
A hidden treasure trove of ideas.
So, thinking back on everything we've discussed today,
It's quite a story, isn't it?
it really is.
It's not just about the scientific discoveries.
Yeah.
It's about peering into the mind
Right.
of a true polymath.
Huygens was a true polymath.
Someone who saw these connections.
Yeah.
Where others saw only disparate fields.
He tackled cosmic mysteries,
Yeah.
revolutionized timekeeping,
And laid the groundwork for our modern understanding of light.
all while grappling with the very human challenges
Right.
of scientific rivalry.
The pressure to innovate.
And even in his final work, Cosmotheros,
Yes. Cosmotheory.
he's envisioning alien societies.
Pondering the possibility of life beyond Earth.
It's incredible how he was able to balance
It really
that
is.
grand cosmic vision.
With such meticulous attention to detail.
He was mapping the rings of Saturn,
Yeah.
figuring out the scale of the solar system,
Yeah.
while also perfecting the mechanics of a clock
I know. It's mind-boggling.
that could measure time with unprecedented accuracy.
It's like he saw the universe as both this vast, awe-inspiring spectacle,
And a finely tuned machine,
all interconnected.
governed by the same underlying principles.
And that's what made Christiaan Huygens such a remarkable figure.
He was a brilliant theorist
A skilled craftsman.
and a visionary who dared to imagine the unimaginable.
He truly embodies the spirit of scientific discovery.
That insatiable
That
curiosity
relentless pursuit of knowledge.
and that willingness to challenge established ideas and push the boundaries of human understanding.
I think we could all learn a thing or two from Christiaan Huygens.
I agree. So as you go about your day today,
Yeah.
remember Christiaan Huygens,
Nafteling.
who saw the universe as both this vast, awe-inspiring spectacle.
And a finely tuned machine.
Perhaps his legacy will inspire you to approach your own challenges.
With that same blend of intellect, ingenuity, and a healthy dose of wonder.
Thanks for joining us for this deep dive into the world of Christiaan Huygens.